Our next speaker is Professor Lori Krause's astronomy student, Ms. Catherine Wilson. She will be presenting on Mars is in Sight, an InSight mission situation report.
Hello, everyone. First of all, I'd like to thank everyone who made this symposium happen and made sure I was here to perform or speak to you. And thank you, all of you, for coming out today to support the field of science. As scientists, we're enamored by the pursuit of truth and knowledge because we know it's imperative to our success at all levels. I sincerely hope that you join in us in sharing our excitement for science throughout the community and beyond. Personally, I find space exploration to be one of the most exciting frontiers of modern science. And I'm really happy to be able to share with you today the progress of NASA's InSight mission, which is studying the planet Mars. In this situation report, I would like to answer 3 questions that you may have. What is the mission of InSight? How much progress has it made so far? And what does its future hold? So, what is the mission of InSight? The 2 main science objectives of the mission are to better understand how Mars was formed and has since evolved, and to determine how geologically active the planet is with respect to tectonic and meteorite activity. Specific goals include determining the size and state of the core, whether it is a solid or a liquid, determining the composition of the mantle and how thick the crust is, as well as determining the frequency of seismic and meteorite activity. The InSight lander was heavily based on the design of its predecessor, the Mars Phoenix lander, and features a robotic arm with an attached grapple. Also equipped are 2 full-color cameras, the instrument deployment camera positioned on the arm and the instrument context camera mounted on the edge of the lander, which recently took these photos of Martian clouds. I think that is so cool. There are 2 primary science instruments and 1 secondary instrument equipped on InSight, all of which remain stationary for the duration of the mission, which is projected to be 1 full Martian year, or 23 Earth months. The seismic experiment for interior structure seismometer, or SEIS for short, is bolstered with wind, pressure, temperature, and magnetic field sensors to make precise measurements of the surface vibrations generated by Mars quakes, meteorite impacts, or weather. This data can help determine the structure and composition of Mars' interior. The Heat Flow and Physical Properties Package, or HP3, is a small probe that is designed to drill its way down into the Martian crust and simultaneously collect data on the interior conditions of the planet, collect data on the interior temperatures of the planet, further indicating its interior conditions. This information can also help scientists confirm the theory that Mars and Earth, and likely the other terrestrial planets, were in fact formed at the same time from the same material. The Secondary Rotation and Interior Structure Experiment instrument, known as RISE, sends and receives signals daily to and from its team on Earth, who over the course of the mission will be able to detect small changes in that signal as a result of the Doppler shift caused by Mars' slight wobble on its axis. In addition, RISE will also be able to measure slight changes in the length of the Martian day as its rotation rate is affected by seasonal changes. With the data collected by RISE, scientists hope to improve their overall understanding of the planet's core, the mechanics of the core, and the resultant magnetic field, which we know is notably weaker than that of Earth's. So now that we know a little bit more about the mission of InSight, what progress has it made so far? On May 5th at 4:05 a.m. Pacific time, InSight launched from Vandenberg Air Force Base in California. After separation from the launch vehicle, the spacecraft cruised for nearly 7 months, navigated by star tracking guidance systems, sun sensors, and a gyroscope. Over the course of its millions of miles, the spacecraft successfully completed 6 trajectory correction maneuvers using its 8 onboard thrusters. The entry and descent phases of the mission included a parachute descent for initial deceleration of the spacecraft, as well as a guided descent powered by 12 engines to ensure a gentle touchdown. Let's take a look.
2,000 meters per second. InSight has passed through peak deceleration. Telemetry shows that the spacecraft fell about 8 G. InSight should now be experiencing the peak heating rate. Some stations are observing signals consistent with parachute deployment. Altitude convergence, the radar is locked on the ground. Yes. Standing by for lander separation. Lander separation commanded. Altitude 600 meters. Altitude 400 meters. 200 meters. 80 meters. 60 meters. 30 meters. 20 meters. 17 meters. Standing by for touchdown. Touchdown confirmed.
So you can see a lot of work goes into these missions, and we're very, very happy. 6.5 minutes after InSight entered the Martian atmosphere, approximately 80 miles above the surface, it successfully landed at the Elysium Planitia on Mars at 11:53 a.m. Pacific Time, November 26, 2018, marking Sol 0 of the mission. You may or may not be familiar with the SOL system for tracking time on Mars missions, but a SOL is a Martian day, which is slightly longer than an Earth day, and every mission begins at Sol 0. Shortly after landing, InSight autonomously opened its fan-like solar panels, as well as performing system health checks and snapping a photo of its surroundings before preparing to go into sleep mode for its first night. While RISE began collecting data within a few days of landing, full-on data collection didn't fully begin until about 10 weeks into InSight's habitation on Mars, after the lander and its team had the chance to assess the environment and establish the primary instruments. After determining the best location on December 19, 2018, InSight's robotic arm deployed the SICE seismometer and later its protective dome and shields on February 2, 2019. Shortly after, on February 12th, the robotic arm also deployed the HP-3 probe on the Martian surface, where it began burrowing itself into the ground about 2 weeks later. The probe is currently in this burrowing phase, where it's slowly and deliberately hammering itself 5 meters down into the Martian surface, while it simultaneously is collecting data by sending out pulses and testing the thermal conductivity of the surrounding soil, kind of indicating what the soil is made out of. The nearby seismometer is also able to detect these small vibrations made by the probe as it digs, allowing it to map out the shallow layers of the subsurface. The exact location for the probe was very carefully considered, because encountering a rock of any kind would mean taking a considerable amount of time to resolve the resulting data, among other complications. But unfortunately, after only a couple of digging cycles, the probe stopped making progress, and data indicates that it is tilted, possibly due to rocks or gravel. So the InSight team, they've suspended digging right now, but they are working on solutions for it. But on a more positive note, recently on April 6th, the seismometer did detect its very first Marsquake. The mission, currently at Sol 160, is expected to last 709 sols, or approximately 2 Earth years, until November 24th, 2020. As you can see, InSight has made some very exciting progress so far, but what does the rest of its future hold? As the lander continues to adjust its instruments and establish routine data collection, it will continue to provide constant weather reports, including air temperature, wind speed, and atmospheric pressure readings measured by the lander's temperature and wind for InSight or TWINS instrument. Even after the official conclusion of the InSight mission, there is the possibility that NASA will continue to use the lander for supplementary science and data collection, as it has done with many of its past space explorers. And even at the inevitable point when data is no longer being collected and sent back to Earth by InSight, it will likely take years or even decades to fully analyze the data set, ensuring the InSight's relevance for years to come in the foreseeable future. And for more information, including mission updates, photos, and videos, you can visit the mission website or follow InSight on Twitter. Are there any questions? Thank you so much.